Well, hello again. Here is my second attempt to try to explain experiment 21, part C. Okay, what's going on here is we're going to have 4 bottles with unknowns in them, and labeled A, B, C, and D. And in one of those bottles will be 0.1 molar hydrochloric acid, another 0.4 molar hydrochloric, another one 0.1 molar sodium hydroxide, and the fourth will be 0.4 molar sodium hydroxide. We don't know which is A, B, C, or D. That's the point. We're trying to find out which is which. In 2 of the bottles, in both of the acid bottles, there will be this indicator called phenolphthalein. Now, what phenolphthalein does is, in an acidic solution, when there's more acid than base, like in the 2 acid bottles, it's clear. It looks like just water, really. But when there's more base than acid, when it's a basic solution, then the phenolphthalein turns pink. The idea is to figure out what's in what bottle, and the only thing we can do to figure that out is to mix the solutions from the different bottles together and see what happens. Right. With the idea being that after we finish the mixing, if the solution is basic, it'll be pink. If it's not, if it's acidic or neutral, it'll be clear. Okay, here are the 12 possibilities for mixing. The order matters. We know which we mix to which. And if we mix, okay, so over here, the 0.1A, that stands for the 0.1 molar hydrochloric acid. The 0.4A stands for the 0.4 molar hydrochloric acid. The 0.1B stands for the 0.1 molar sodium hydroxide base, and 0.4B is a 0.4 molar sodium hydroxide base. So if we mix the 0.1 acid with the 0.4 acid, because it's still acidic, it's going to be clear. And likewise, 0.4 adding to 0.1 acid, it'll still be clear. And if we add base to base, 0.1 to 0.4, or 0.4 to 0.1, because there's no phenolphthalein present, it's a basic solution. If there were phenolphthalein, it'd be pink, but there's no phenolphthalein because that's only in the acid solution, so it'll still be clear. So the C stands for clear, P is going to stand for pink. Now if we take, so that's 4, there's 12 possibilities for mixing, that's the first 4. The second 4, if we take 0.1 molar acid, added a 0.1 molar base, as soon as we add a few drops of the 0.1 molar acid, there's going to be some phenolphthalein present, but there will be more base than acid, and so it'll start pink, and then eventually it'll turn clear. Now the way we're going to do this, I'm going to do it, is I'm going to take 12 test tubes, and in them I'm going to put 20 drops of bottle A, B, C, or D. And I'll show you the scheme in a moment. It's down here. And we're going to add, dropwise, another solution. Here's what it looks like. So we're going to take 20 drops of B, put it in test tube 1, 20 drops of C in test tube 2, 20 drops of D in test tube 3, and then 20 drops of A in test tube 4, so on, all the way across. Up here, this is the solution that we're going to add dropwise to the test tube. So I'm going to take bottle A, and I'm going to dropwise add it to the test tube with the solution from bottle B in it, and then bottle C and bottle D. And what I'll do, because there's 20 drops in each of the bottles, in each of the test tubes, what I'll do is I'll add 10 drops from the bottle, and this one from bottle A to test tube with B in it, stop, see what happens, then add 10 more drops, so we have 20 drops of each, and then I'll add 10 more for a total of 30, and we'll see what happens. And I'll do the same, adding B to A, C, and D, C to A, B, and D, and D to A, B, and C. So the possibilities are, okay, if it's acid to acid or base to base, these 4 up here, it's going to just be clear. If we add the 0.1 acid to the 0.1 base, because when we first add the first few drops of the acid, now there's phenolphthalein present from the acid solution, but there's still more base than there is acid, so it'll be pink. But when we've added about 20 drops of the acid to the 20 drops of base that are in the test tube, the base will be neutralized by the acid and it'll turn clear, and it'll stay clear to 30 drops. If we switch it around, we add the 0.1 base to the 0.1 acid. At first, because there's phenolphthalein present, right, it can be pink, but it won't be because there's more acid than base, until we've added the same amount of base as there is acid. So there's 20 drops of acid in here. If we add 20 drops of base, Now it'll still be clear, but as we keep going, go to 30, then there's going to be more base than acid. There will be phenolphthalein present, so it'll turn pink, clear to pink. If we go 0.1 molar acid to 0.4 molar base, okay, as soon as we add a few drops of the acid, there's going to be phenolphthalein present. There's always going to be more base than acid present, so it'll turn pink and stay pink. If we add 0.4 molar base to 0.1 molar acid, as soon as we start adding the base, it probably be clear for the first few drops, but then because the 0.4 molar base is 4 times as strong as the acid, after a few drops, there should be more base than acid, and so it should turn pink after a few drops. If we add 0.4 molar acid to 0.1 molar base, it's going to start out pink because at first there's going to be more base than acid, but after a few drops it should go from pink to clear because now there will be more more acid than base. If we add 0.1 molar base to 0.4 molar acid, at first it's going to be clear, and then because we still have way more acid than base, this is 4 times as concentrated as the base is, it'll stay clear. If we add 0.4 molar acid to 0.4 molar base, it should turn pink at first because as we add the acid, we're putting phenolphthalein in, there's more base than acid, it'll be pink. But then after 20 drops or so, the base has all been neutralized by the acid, so it'll be clear. 0.4 molar base to 0.4 molar acid, at first it'll be clear because there's more acid than base, but after we add about 20 drops, and then a little bit more probably, there'll be more base than acid, so it should turn pink. Right. So here's what you should have in your notebooks, something like this. And what we're going to do, I'm going to mix the solutions for you. You're going to watch tomorrow. You'll just note what happens. Is this pink? Is this clear? Is it pink to clear, clear to pink? Okay, make notes about each of those. And from there, you should be able to figure out what's in bottle A, what's in bottle B, what's in bottle C, and what's in bottle D. All right. Hope that helped.